We just haven't looked at the standard form of that yet, so that's mainly what we're going to look at is this. Okay, so I'm going to show you how to do graphs of quadratic equations. Yes, go ahead. You need a packet? Is there any more 4.3s out there? Because I just passed them around. You may have missed one. I think she's got more up there. And then you need a 4.4 too if you need that. Okay, so first of all, this is the standard form. This is what you're familiar with. ax squared plus bx plus c is your standard form. And then this is your vertex form. That's what's new that we haven't talked about yet. Thank you. Okay, so hk is the vertex. The vertex is just, this point here, okay, where the parabola comes to a point and where it's symmetrical about like that. Okay, a couple of things that you want to be sure that you're aware of. If this number a is positive, well, that means the parabola is going to open up. Okay, if this number a is negative, then that means the parabola is going to open down. That's because it's a reflection. Those are things that we've talked about before already. Okay, so what I want to start with is I want to get you comfortable with how you do a graph of a quadratic if it's in standard form. Okay, so we're going to do this like this then. Okay, first of all, the way the vertex goes on this one, the vertex on this one, it's just like it is on a circle primarily. So this right there is saying that you're going to the right 2. So your vertex is going to have an x value of 2. That 4 is saying that you're going down 4. So when you're getting the vertex, what I want you to think about is what your transformations are. The x minus 2 moves you to the right 2, like we learned. The minus 4 moves you down like that. So first thing I'd like you to do is just plot that, go ahead and plot that point then. So you're over 2, up 4. That's going to be your vertex. Then the next thing I'm going to have you do is do a dashed line straight through it, like that. And we call this the axis of symmetry. So we say x equals 2 is the axis of symmetry. And then what I'm going to show you how to do, because this is real handy if you learn how to do this, because you don't have to do too much calculation. So anytime the number in front, if that's a 1, okay, then there's no stretching or shrinking. So pay attention to this. This is what you want to learn how to do. Okay, so what did I do that wrong? That's a minus 4. Yeah, that's a minus 4. I just caught that. Okay, so that vertex should be there. Okay, because again, that's down 4. So you're going right 2, down 4. So sorry about that. That is where your vertex is, okay? Now, pay attention to this. If that number in front is 1, then here's what you're going to do. From the vertex, if you go over 1, you're going to go up 1 to the second because it's a squaring operation. If from the vertex you go over 2, then you go up 2 to the second, which is 4. Okay? If you go over 3, then what do? You go up 3 to the second, or 9. Okay? If you learn that right there, then you can get as many points as you want to, and you can get them perfectly accurate without doing any calculation whatsoever. So what you'll do is go to your vertex, go over 1, up 1. That's a dot. That's a perfect point on the parabola. Then if you go back to your vertex, if you go over 2, then go up 1, 2, 3, 4, and put a dot there. Okay? Do the over 3, up 9. So if you go over 3, then you'll go up 1, 2, 3, 4, 5, 6, 7, 8, 9, like that. Okay, and then that would be the right half of your parabola. Okay? What if you went over 4? Then what would you go up? 16. Over 5, up 25. Everybody caught on to that? Okay? That's important because that way you can do your graphs very easily. Now it's symmetric, so you just reflect these points over that axis of symmetry. Okay, so you can just reflect those over, and once you get the right half of that, then the left half you just reflect it to get that. So that would be what the graph of that quadratic equation is. Okay, if you've got that in the vertex form, then it's real easy to graph that then. Okay? All right, let's look at this next one. What does the plus 3 do? How does that change the parabola?
Left 3.
It goes left 3. What does the plus 2 do? Up 2. Okay, so you're left. So that means your vertex is going to be negative 3, positive 2. Okay? So what you're doing on that, if you think about those transformations, that'll help you. So you want to go ahead and plot that point, left 3, up 2. Then you can put your axis of symmetry through that. Sometimes my math lab wants you to do that. Sometimes it doesn't, but that's what I mean by axis of symmetry. Okay? All right, what is that negative going to do? It's going to go down. Okay, so you're going to do the same thing we just did. See, if that's a negative 1, what you're going to do is over 1, down 1, over 2, down 4, over 3, down 9, and so forth. So we know it reflects, so what you want to do is you want to do this. Just go over 1, down 1, go back to the vertex, over 2, down 4, and then one more time over 3, and then down 9, which I think would take you all the way down there. Okay? Then that'll give you the right half of the parabola, and then just do your other points reflected over that axis of symmetry like that. Okay, does everybody understand that okay? Okay? All right, so see, that's real easy to do if it's in a vertex form. Then you can get your parabolas graphed very, very easily. Now, I'll get to this in a minute, but if that was a 2, what would that 2 do if I put a 2 there? It stretches everything. It actually just doubles all these y values. So like if you put a 2 there, you would really end up going over 1 up 1, but then you would double that, so it would go up there. Then you would go over 2, not up 4, you'd go up 8, because you double it. Does that make any sense? Yes. Okay, that's what causes it to stretch, is that thing affects the y values if it's a number other than 1. Okay? All right, any questions about that? Okay, all right. Now, I'm not going to do anything with this yet, but there's another way to find the vertex, and I'll get to that a little bit later, so I just want to give you that formula. Don't worry about it right now. I'll show you what to do with that a little bit later in this handout. Okay, so let's go to the next page, and what we're going to do on this is I'm going to show you how to put this in the vertex form. Okay, what's different about this problem is it's multiplied out. We're going to put it in the vertex form by completing the square. Okay, so we want to work on this for a few minutes. Okay, what we want to do is I want you to do this. Put a set of parentheses around x squared minus 4x and leave a little blank there. Now, we've learned how to complete the square. We're going to do this on this a lot like you learned how to do on the circle. So remember, when you completed the square, you did this. You take half of that number in front of x. That gives you negative 2. Then what you do is you square that to get a positive 4. Okay, just like you did on the circle. And you can do that in your head, totally in your head. So what you do is you put a plus 4 here, but to balance it out, I mean, you're working on this side of the equation. It's not like the circle where you have two sides of the equation. Put a minus 4 there. Okay, that way you're not changing the problem at all. Okay, does that make sense? I say I'm working on the same side of the equation because I want my answer to look like this. F of x equals a x minus h squared plus k. I want everything on the right side. That's why I do plus 4 minus 4 so that nothing's different. Does that make sense? Okay, all right. A lot of times students are confused with the circle where we did the same thing to both sides of the equation. Okay, this isn't a circle. It's everything's on the right side. So now what you're going to do is you're going to factor this. Okay, so we factor that. That would just be x and x. It would be 2 and 2 with 2 minus signs like that. And see, that will always factor as something squared. That's the reason why we're completing the square. Okay, so that's the first thing that you want to learn how to do, is how to put that in a vertex form by completing the square. Okay, now let's look at what the transformations are. What does this 2 do? Okay, that's right 2, good. Okay, what does this minus 4 do? Down 4. Yeah, down 4. Okay, that's one way to help you understand what the vertex is. So if you go to the right 2, then you would have 2. If you go up 4, that would be positive 4. So the vertex is 2, 4. Okay, all right. So you gotta, if you think of it that way, you won't get your signs confused. Sometimes students get their signs confused. This is giving you 2. That's giving you negative 4. So it's kind of like the opposite sign there and the same sign there. But don't think of it that way. Think of what your transformations are. Okay. So now we're ready to graph. So we want to go ahead and put your vertex. So you go over 2 up 4 like that. Your axis of symmetry is going to go straight through like that. Okay, the equation of that axis of symmetry is x equals 2. Because remember, if you have a vertical line, that equation is x equals whatever the x value is. So it goes like that. Okay, look at this right here. Is this going to open up or is it going to open down?
Open up.
Opens up. How do you know?
It's a positive number.
Positive number in front of the parenthesis right here. See, that's a positive 1, isn't it? So that's going to tell you that you're going to open up. All right? Yes, go ahead.
Isn't that supposed to be the point supposed to be -4 instead of a 4?
I did the same thing I did a minute ago. Okay, yeah, okay, that's -4. I even said it was down, so it goes like that. So let's correct ourselves before we get too far into this. Thank you. Yeah, it's down 4, so it's going to be -4. Okay, that's the second time I've done that. Great, so put that to -4 like that. Now we're ready to go through and just get the points. Okay, it's opening up because the number in front's positive, and then do exactly what I taught you a minute ago. Go over 1, up 1, over 2, up 4, and that's good enough. You don't have to go over 3, up 9. I just want to get 5 points. So then do the other points like that. And then that will give you a absolutely perfect graph of what your parabola looks like. Okay, so if you can get that in vertex form, then that's how you put that together. Okay? All right, does that make sense? Okay to everybody? Okay? All right, now we're going to learn a different way to do this vertex in a few minutes, but the completing the square is a good way to start with doing this. Okay, so let's go this next one. Now I want to ask you a question on this. By looking at that, is it going to go open up or down?
Down.
Down, because you have a negative x squared, right? So one thing that you might want to make a note to is you're opening down. You already know that, okay? So we're going to go ahead and complete the square on this. And watch carefully, because you got to be really careful about what you do when you complete the square on these. So put a parenthesis around the first 2 terms and just leave the constant, the -9, outside like that. That's how you want to start that. Okay, the next thing, you do not want to complete the square yet. What you want to do is you want to take this negative and you want to pull it out. You want to factor that out, okay, because you want to write this in the right form. So if you do that, that's going to change these signs. That's now going to be x squared minus 12x, then a parenthesis and -9 like that. Okay, make sure you don't change anything. I haven't changed the problem. I just need to take that negative out. Okay, now we're ready to complete the square. All right, you can do this in your head. So if you do -12 over 2, that's -6. If you square the -6, you're going to get +36. Okay, like that. All right, now watch the next step very carefully. This is where students always mess up. Okay? So a lot of times students are going to think +36 minus 36. That's wrong. Because I didn't add 36. What did I really do? I added -36, right? That's a -36. So to get that balanced out, you got to put a +36 there. See, that's -36. So put a plus there. You got to really, really watch that carefully on these problems. Negative there, plus there. Okay? You just got to make sure that I haven't changed the problem. I have not changed that problem. If you put all the like terms together, you'd be back to the beginning. Does that make sense? Okay, so pay attention to that negative in front of the parenthesis. Now what's going to happen is you're going to factor this, and this is going to factor as x minus 6 times x minus 6. Okay, and then this is going to be, what's that, +27? Yeah, +27. So it's going to go like that. So you would write this then as negative x minus 6 to the second +27 like that. Okay, are you with me?
You put something to it.
Did I do this? That's the dyslexic thing there, okay? All right, I've been doing stuff like that all day today. Okay, so there we go. All right. Okay, so now what we have on that is, what are the transformations? Right, 6, good. Okay, and the 27, what's that? Up 27. Okay, so that's where your vertex is. Your vertex is going to be to the right 6, and then over 27 like that. Okay. Now that's way out of range, so all I'm going to do on this is I'm going to kind of do this. Okay, so we're just going to do this. Let's go through and maybe just change this to like 5, 10, 15 or something like that. I just want to get a rough graph on this one anyway. 25, and then 30 like that. Okay, all I want to do is just get maybe the vertex and kind of a rough graph of what this looks like. Okay, so let's see, if we plot that point, 6, 27, we'll go over 6, then up about 27 like that. And your axis of symmetry will go like that. Okay, so the equation of the axis of symmetry is x equals 6. Okay, now what I'm going to do on this is I'm not going to be very accurate on this. So I would go, you would open down like we talked about because of the negative. So it would just be over 1, down 1, over 1, down 1, and that's good enough. On this problem, that's fine with me. Okay, all right. So that's the idea. The biggest part of this problem for most students is doing the completing the square. And once you get that put together, you can get the vertex, and then you can get your parabola done pretty quickly. All right, everybody okay with how that goes? Okay. All right, I want to work a little bit. There's lots of things that can happen on completing the square, so I want to show you the different things that you will encounter if you do this. Okay, this next one. Does this open up or down just by looking?
Up.
Opens up. That's because the number in front of x squared is positive. You know that automatically. So the big part of this problem is going to be putting this in the vertex form. Now, there's a lot of benefit to knowing how to do this, okay? So watch carefully. This is a little harder than the last one even, because you're going to end up having fractions. So you always start this the same way. You want to put a set of parentheses around the terms that have x and leave the minus 7 out the side like that, okay? Now remember, what you're trying to do is you're trying to write this in the form a x minus h squared plus k. So you have to pull that 5 out, okay? You absolutely have to. So when you do that, you're going to have 5 parentheses, x squared plus what?
2x.
2x, then a gap, minus 7 like that. Okay, so you got to start that way, all right? Okay, now you're ready to complete the square. So do the 2. What are you going to do? What's half of 2? 1. What's 1 squared? 1. Okay, so what you're going to do is you're going to put a plus 1 there. And now you got to watch this real carefully. This is where students have the hardest time. Okay, plus 1 minus 1? What did I do? 5, right? Plus 5 minus 5. All right, see, that's really a 5 because 5 times 1 is 5. So if you put a minus 1 there, you're changing the problem. Plus 5, minus 5. That's how it goes. Do you guys understand that okay? Pay attention to that, okay? So we're going to go plus 1, minus 5 like that. All right, and that's just because, whoops, that's because this and that are the same thing. They balance out. They cancel, okay? So now when you put this together, you're ready to do your factoring. So we do the factoring, which would be x plus 1, and then you put the terms together there. That would be minus 12. So you would end up having f of x equals 5 times x plus 1 squared minus 12 like that. All right, that's what we have accomplished. Okay, what are the transformations in this problem?
Left 1.
Left 1. And what else?
Down.
Down 12, exactly. Okay, I'm going to be real careful this time. Okay, so what's the vertex?
Negative 1.
Negative 1 because you're left, and then what?
Negative 12.
Negative 12 because you're down. Okay, like that. Okay, so that's your vertex. The axis of symmetry is always just x equals whatever that x value is. Okay, so it's always going to go through that. All right, so let's go ahead and let's do a graph on this then. So we're going to go left 1 and then down 12. I'm not going to do the axis of symmetry this time. Now what's going to happen on this, now watch this real carefully, all right? What we've been doing on this is we've been going over 1, up 1. Okay, that doesn't happen anymore because that's a 5. So what are you going to do? Over 1, up 1 times 5. Over 2, up 4 times 5. You see what I mean? So it's over 1, up 1, over 2, up 4, but that 5 is going to cause it to stretch, so it goes like this. Write a note to yourself if you need to. Over 1, up 1 times 5 would be 5. Okay? Over 2, now it would be instead of up 4, it would be up 4 times 5, or 20 like that. Okay? That's how the stretch works on that. That's why it works. Okay, that's handy to know how to do that then. So from this, we're going to go over 1 and then up 1, 2, 3, 4, 5. Okay, so I think I got that right. And then if you go over like this, okay, see, that's really negative 12, and you don't have to count all those dots. If you're going over, then negative 12 up 20 would take you up to 8. So what your next point would be right there. Okay, well, you don't have to count. Okay, you can if you want to, but you do that, and then the rest of these points are symmetric. So it would kind of go like that. And there's your graph, and you can see that it's stretched a lot because of the value of that 5. So that's how that goes. Okay, if you don't like doing that over and up, then you just have to plug numbers in and calculate. You'll get the same result. To me, it's easier to learn it that way because you can get that done a little bit quicker. Okay. All right, is there any questions about what I just did? Okay. Now, let's do something a little bit different with this one. There's a little bit more I want you to do on this one. So we're going to go ahead and complete the square on this one also. Okay, so go ahead and do that. And what I want you all to do right now is I want you to go ahead and complete the square. Don't wait for me. And then see if you can get your vertex and your axis of symmetry. Then we'll do a graph. I didn't give you any graph paper on that, so it doesn't matter. I'll probably have you just sketch one. Then we're just going to answer some questions about this. There's a few questions we're going to go through and we're going to answer them. Okay? So have you got your standard form? You got that? X minus 1 squared minus 1. Okay. So what's the vertex? 1, negative 1. Okay, that's to the right 1. And that's down 1. Okay, so that should be 1, negative 1. What's the axis of symmetry?
1.
X equals 1. Now you want to put an equation there. Okay, so remember it's always X equals whatever that X value is right there. Okay. Does this thing open up or down?
Up.
Up. Okay. Is there any stretching?
No.
Nope, there's nothing in front of that parenthesis, so there's no stretching. So what means what you want to do, just sketch out your graph, is we'll go ahead and we'll put our vertex. Our vertex was over 1, down 1, like that. And then we're just going to get two other points. Okay, that's good enough for what we're doing on this. Okay, so from here, if there's no stretching, what do? Over 1, up 1, would go like that. And then left 1, up 1 like that. And then you can just kind of sketch that in. Usually I like you to have about 5 points. Okay, the vertex and then 4 other points is generally what I like you to have. Okay, now what we're going to do is we're going to go back to things we've talked about before. Okay, where is the function increasing? From where to where? Remember, you use X values when you do that. From there to infinity, right? Okay, from there to infinity you're increasing. How about decreasing? Way over there, negative infinity, until you get to 1, okay? So we've talked about increasing and decreasing, and you name those things with X values, okay? So the decreasing is this part here that I'm highlighting in blue. So that's going to be negative infinity until you get to the X value 1. Use X values, okay? And then the increasing will be the part I'm highlighting in yellow. So that's going to be from 1 to infinity like that, okay? All right, does this thing have a relative maximum? Just a second here. Does it have a maximum? No. Does it have a minimum?
Yes.
Yep, okay. This point right here is your relative minimum, like that. So that's your relative minimum. So again, we don't have a maximum. The relative minimum is just the vertex. Okay, and it always will be on a parabola. The vertex is either a max or a min. It can't be anything else. Does that make any sense? Okay, it's either opening up where it's a minimum or it's opening down where it's a maximum. Okay, did you have a question or are you okay?
Yeah, it was Back to the increasing and decreasing.
Yep.
Wouldn't it be brackets on the outside of the one, or no?
No, that's something that I think I caught on the test, is anytime you do increasing and decreasing, you always use open intervals. Okay. That's the thing on that is, it doesn't matter that you have a point there, it's just they are open intervals. Because what happens, at this point right here, we don't consider that to be increasing or decreasing. Okay? And what you learn like in a calculus class is you're increasing when the slope is positive. Okay? That slope is 0. You learn that you're decreasing when the slope is negative. Okay? At this stage of college algebra, just use open intervals. That's what you're going to learn. You get into that a little bit more in a calculus class. Okay, does this thing have an x-intercept? It has 2. The 2 x-intercepts are 2, 0, and also 0, 0. Okay, those are your 2 x-intercepts. Your y-intercept is the point 0, 0. Okay, so I'm just doing that observationally by looking at that graph. Okay, there's other ways we'll look how to do that in a few minutes. Okay, all right, is there any question there? Completing the square, that's the key thing, is what we're doing there, that you got to make sure that you have a good handle on. Okay, this one I'm going to do one more like that, and then we're going to transition to learning a different way to do the vertex. Okay, so let's go ahead and let's try to complete the square on this one. And then I'm going to do the graph at the very end of this problem this time. So we'll do all the x-intercepts and y-intercepts, everything without even looking at the graph. Okay, so let's go ahead and let's start off how we're going to do this. First thing we're going to do is put parentheses around the x's, leave a blank, and then we have the -5. Okay, what do you have to do next? Pull the negative out, right? You have to, okay? You don't want a negative in front of x. Pull that out. So when you have that, then you're going to have negative x squared, what? Plus 6x, got to change the sign, -5 like that. Okay, make sure that you handle that correctly. All right, complete the square on 6. What's that going to be? Half of 6 is 3. 3 squared is 9. So you're going to have a +9 there. Okay, let's see if we've caught on to this. What do I put here to balance it out? A plus or a minus? Plus, good, okay. That's a negative, right? So to get that to go away, put +9 here. You have to pay attention to that. Okay? If you don't pay attention to that, you're probably going to mess that up. Okay, so what I'm going to do there is put a +9 like that. Okay, so now what I'm going to have is negative, and I'm going to factor this. This is going to factor as x plus 3 times x plus 3, and then that's going to make a +4. -5 plus 9 is +4. So you'd end up having f of x equals negative x plus 3 squared plus 4 like that. Okay, we're not going to do the graphing. I don't want to even go to the graphing yet, okay, because I want to do the rest, everything on this problem without graphing, and check with your graphing. Okay, all right, what's the vertex? -3, 4, right? Okay, you're going to the left 3, and you're going up 4, so it would be that. What's the axis of symmetry?
-3. X is equal to negative.
X equals -3. Okay, that's what you look at on your axis of symmetry. Okay, before we do the graph, is this thing opening up or down?
Down.
Down. Okay, so is that thing right there going to be a minimum or a maximum?
Maximum.
Okay, because it's opening down, that means you're going to have a maximum, but you're not going to have a minimum, right? Okay, the maximum is the vertex. So that is the point. We already know that vertex is -3, 4. So that's going to be the maximum. We don't have a minimum. If you know that it's opening down, you already know that, see. Okay? How about increasing? Where's this increasing from? -infinity to -3 with an open interval. Decreasing, -3 to infinity. Now you're going to know that because you know that it's opening down. Okay? So you're going to increase from -infinity to -3, you're going to decrease from -3 to infinity, okay? Now, we're not going to graph because we're going to find the x-intercepts without graphing. Sometimes you have to do it without graphing. Okay, so the way you find an x-intercept is, and we've talked about this, is you set y equal to 0. And I would recommend that you go all the way back to the beginning. I mean, you don't have to, but I'm going to just say, let's go all the way back to the beginning. So what you're going to do is take that and set that equal to 0 and solve that equation. Now that's a quadratic equation that can probably be solved by factoring. Now what I suggest, if you have a quadratic equation and the x squared term has a negative, I suggest that you turn that to a positive because it makes factoring easier. You actually don't have to do that, but I'd recommend it. So what I'm going to do is I'm going to have you multiply both sides of this equation by -1. And then the factoring you'll find to be a little easier. So that's x squared plus 6x plus 5 is equal to 0. When you factor, you're used to having that x squared term being positive. Okay? All right, so let's go through and factor this then. Okay, we have x and x. You have 5 and 1. So the signs are going to go plus 5 plus 1 to make the 5 and 1 add up to 6. So in your head, what are the two solutions of that equation? -5, -1. Okay, so that's given a -5, that's given a -1. Now your x-intercepts, I typically want you to write those as coordinates. So let's say -5, 0 and -1, 0 like that. Okay, so those are your two x-intercepts that we have. Okay, now we want to go through and we want to find the y-intercept. And what do you do to find a y-intercept? You set x equals 0. It's usually easier to find a y-intercept because you just go back and everywhere you see an x, you plug in a 0, so you'd have -0 squared minus 6 times 0 minus 5. So what is that? -5, right. Okay, the zeros cancel out, so that would be 0, -5 like that. Okay, I said we want to do the graphing at the end because we have more information now. So when we do our graph, this is what I want you to do. Let's just plot the vertex. Let's go left 3, down 4. Okay, let's go ahead and let's do the axis of symmetry. We know it's opening down on this. Okay, so we got, I keep doing, that's like the third time I've done that. Okay, I can't plot points today for some reason. Okay, so let me fix that. That's -3, 4, so we're going to go left 3, up 4 like that. Okay, we'll go ahead and put your intercepts. Okay, we have a x-intercept, -5, 0. We have another x-intercept, -1, 0. And we have a y-intercept, 0, -5. You don't have to do anything other than that, so you've got lots of good points. So that's perfectly acceptable to just use those points right there. Okay, so if you got x and y intercepts, just use them. Okay, all right, so that's the idea with that. Now what we're going to transition into next is it turns out you can do without learning how to complete the square. I recommend that you learn how to do that, but there's a second way to do the vertex if you don't like doing it this way. Okay, so that's what I'm going to show you next on the next page. All right, so any question about what I just did? Okay, all right. So the next thing we're going to do is we're going to learn how to do a vertex without completing the square. So actually you just use this formula, and all you got to remember is the x value is just of the vertex is always going to be -b over 2a, where you have a quadratic equation. And that comes from the quadratic formula. The quadratic formula has a -b at the beginning, and it's all over 2a. So it comes from that point like this. So let me show you how you could do this. On this example, if you didn't want to complete the square, well, you would just say, okay, a is -1, b is -2, c is -5. So what we're going to do to find the x value of the vertex, you're going to do -b over 2a. So you're going to have a negative, and be careful here, it's negative of -2. So that's -2 all over 2 times -1. So that's 2 over -2. So that's -1. Okay, so you would end up having, just by doing that simple calculation, you've already got the x value of the vertex, right? Okay, well, what if you want to find y? If you know x, how do you find y? Plug it in, right. Plug it in. Okay, exactly. So what you want to do is you want to do f of -1. Okay, so just take the function I gave you, everywhere you see an x, plug in a -1, and then calculate. So this is going to give -1 plus 2 minus 5. Now be careful about this place right here. If you square a negative, that becomes 1. but then that negative reattaches. Sometimes students slip up on that part right there. So if you put that together, then that would be 2 minus 6, so that's negative 4. Okay, if you like doing the problem that way better than the way I showed you before, you're more than welcome to do it that way. I don't care. Okay, just want you to know how to do it right. Okay, there's benefits to doing it either way, really. Okay. Okay, now another thing I want you to look at is if you look at this parabola, what's it doing? Opening up or down?
Down.
Down. So is the vertex a max or is it a min?
Max.
It's a max. So that would be a relative max because it's opening downward. Okay, so a lot of times on your homework they may say, is it opening up or down? That's all you got to do. Is you got to know if that's a max or a min by how the parabola orients itself. Okay, does everybody understand okay how I did negative b over 2a? Okay, that's your second way to do that. And we're going to do a few more problems that way, and then we'll finish up with a couple of applications that we'll need to do on our calculator. Then we'll start into this next section. Okay, number 8, we're going to do this the second way. If you want to do the negative b over 2a, then don't do any completing the square. This is 5x squared plus 5x, so a is 5, b is 5, what's c?
0.
It's not there, so it's 0. And it turns out it doesn't matter. All you got to know is what a and b is. Okay, so we're going to go ahead and do the x value of the vertex by doing negative b over 2a. Okay, so just plug into that formula. B is 5, a is 5, so you would have negative 5 over 10, and negative 5 over 10 is going to reduce to negative 1/2. So I'm just doing that in my head. So I end up getting the x value of that vertex is negative 1/2. Okay? Now when we get this y value, don't use decimals. A lot of times students want to turn all their fractions into decimals. Bad idea. Deal with the fraction. Okay, seriously, you want to do that. Okay, because sometimes decimals you have to round. We want to get this exact. So now what we do to get the y value is we do f of negative 1/2. So you want to go to your function that I gave you, 5x squared plus 5x, and you want to replace all of the x's with negative 1/2. I'll just crunch out the details, okay? You got to know how to handle fraction arithmetic. So you have 5 here. If you square negative 1/2, what is that going to be? Positive 1/4, right? Because you're just multiplying fractions straight across. So that's going to be positive 1/4. Okay, you go to the next one. That's going to be minus 5 over 2, like that. Okay, so that's going to give you, when you multiply this straight across, you'll have 5 over 4 minus 5 over 2. Well, what do you got to do? Get a common denominator, right? So what's your common denominator?
4.
4. Okay, so that means you need to multiply this by 2 over 2. Now you got to review that. So that's 5 over 4 minus 10 over 4. So that's going to end up being negative 5 over 4. Okay, so that would be your vertex on that problem then. Okay. All right, so what you want to do is negative b over 2a gives the x value of the vertex. And then the next thing is this a max or a min? Okay, well, how do you figure that out? Does this open up or down? Up. Okay, so is that a min or a max? It's a min. Okay, you kind of do that in your head. You don't have to graph on this. It's just that would be a min. Okay, so the vertex is a minimum in that case. All right, so that gives you a second way to do that. When you do your next exam or your homework, you can do it either way. But I do think it's good to learn how to do both the completing the square and this way too. Okay? Okay, so let's go ahead and finish up these two problems here. So you want to get your calculator out on this. So what the applications we do in this section are is we look at quadratic functions. This is a classic example of how projectiles work. So if you throw an object, you shoot a basketball, it follows a quadratic equation's path. Not perfectly, because there's factors like air resistance and stuff like that, but mostly it's going to follow that pretty closely. Okay, so we're going to do this one totally on our calculator. And so you want to just get everything off. The other thing that you want to do is turn your plot off. So if your plot is on right now, get your cursor blinking on plot, press enter to wipe it off, okay? Because now you'll be able to put your function in. Now just put this function in exactly the way I typed on your handout. You're going to have parentheses, -32, x to the second, and then close the parentheses on that. Then you're going to divide by 210 squared. You could actually leave the parentheses off of the 210 squared. The calculator will know what I'm doing. But to be safe, it's generally a good idea to have a numerator in parentheses and a denominator. Okay, then we have plus x plus 100, like that. Okay, now what we're going to do on this is we're going to set the window. I went ahead and gave you a window, just to save a little bit of time. So go to the window. We're going to go 0 to 1500. Okay, and then we're going to scale that probably by 500. Okay, and then for the y's, we're going to go 0 to 600. And then we're going to scale by 100 like this. Okay, so if you get everything put in, let's see if this gives a good graph. You're going to expect to see a parabola opening downward. So that looks good. So if you got everything put in the way I had it written on your handout, then you'll have a parabola that looks like that. Now, as far as doing a graph, really all I want is maybe like 3 points. The more the merrier, but 3 points is good enough. So what this is this would be the x-axis is the y-axis. Let's just go all the way out to, let's see, we said to go all the way out to 1500 on this, and then we're going to go like 500, 1,000 like that. So I'm following the increments that I gave you. On the y-axis, we're going to go 1, 2, 3, 4, 5, 600 like that. Okay? All right. And what this is going to be then is let's just trace out 3 points. So if you want to do this on your calculator, and you'll do this on your next exam, just trace. Okay? What you could do on this is you could go trace 0. Okay? That gives you a point 0, 100. Okay? So all I care about is probably 3 points. Maybe the beginning, the end, and then the vertex probably. Okay? So then what we want to do is let's go ahead and let's trace at maybe 1500. That may be a negative number for all I know, so I'm going to just try. Yeah, it's slightly negative. Okay, so let's just put a little dot kind of right there and maybe label that as 1500 and then -32. Okay, like that. Now, what we're going to do is, since we've learned how to do maximums and minimums on the calculator, we're just going to get the vertex on our calculator. So, again, what you do on this is you go like this, okay? Write the keystrokes if you need to. But what we've been doing is going second, trace, okay? Then we're going to go maximum. So you go second trace, option 4, and then you get bounds. A left bound, you got to kind of work with your left cursor key, and you just got to move that until you're a little bit to the left of where that maximum is. My calculator is a little slow on this computer. So once you get your left bound, as long as you know you're to the left of it, you're good to stop and press enter. And then get your right bound with your right cursor key. Okay, like that. And then press enter. It'll say guess. Press enter again. Okay, and it should give you that maximum. Okay, so I'm going to write that down and just let's round that to like 689.1 and 444.5. Okay, like that. And then just estimate it. It doesn't have to be perfect. Just kind of get a ballpark idea of where that goes. So it's going to be over 600, somewhere in there, up kind of in that range. And then you can connect that like that. Okay? So that would be the vertex like that. So basically what this problem is saying then is the question on here is how far from the base of the cliff is the height of the projectile a maximum. So what that means is how far from the cliff would be this distance here. So what is that? 689, right. Okay, so it's 689. So the answer to the problem would be 689 feet. Because the problem is not asking for the height. It's what it's saying. I mean, you have to find the height, but it's saying how far is that height from the cliff. The cliff is the y-axis. Okay, so that's the answer to the problem. Okay? All right, everybody okay with that? Okay. Now, you've done a lot of this stuff with maxes and mins already. If you're going to take calculus in the future, you'll learn how to do a problem like this without your calculator. You learn how to do a derivative and find maxes and mins with that technique. Okay, we're going to do one more here, and then that'll be a good stopping point here, and then we'll do 4, and I'll do the chapter 5 stuff next week. Okay, so let's put this in the calculator. This is just more like an application in economics. So we're going to wipe out what we have here, and this is a cost function. So let's put in 2x to the second, then minus 30x, and then plus 560. Okay, now that's a quadratic. Is that opening up or down this time? This time it's opening up, and this time you're going to find the lowest cost to the nearest dollar. Okay, I went ahead and worked out a window, so let's put that window in. So we got 0 to 20, and we're going to scale that by 5. Okay, then the y's we're going to go from 0 to 800, and a good way to scale that would be 100. So if you get everything put in, then you want to see that you've got a parabola opening upward like we'd expect, like that. And then what we're going to do on this is find the lowest cost to the nearest dollar. Okay, now let's go and let's do a real rough graph, on 3 points is sufficient. So let's just get let's kind of go like this, 5, 10, 15, 20 to get the x-axis put together. And then for the y-axis, let's go just by hundreds, 1, 2, 3, 4, 5. And then 6, 7, 800 like that. Now again, like if you're doing this with a test or something, if you get 3 points, it's sufficient. So I'm going to trace at 0. So I type trace 0, and that gives me 560. Okay, that's not a bad idea to just label the points as you go. That's 0, 5, 60. I would trace at 20. So I'm going to type trace 20. And that'll give me the end point of the parabola. So that looks like that is 20 and then 760 like that. Okay, now what we're going to do on this, we're just going to do the minimum. So it's the same thing. You go second, trace. This time you go down to option 3, minimum. Press enter, but you still do the same thing. You're still going to do a left and a right bound, but you're now going to get a minimum. Okay, we know that because the parabola is opening upward. You could actually find this vertex, by the way, by doing negative b over 2a. You could do this, you know, without having to rely on your calculator to do this, but I want you to know how to use your calculator to do this. Okay, so it's like a good left bound, and then I move over to get a good right bound. Okay, and then it will say guess. I press enter, and that should give the minimum. So what I'm getting is about 7.5 and 447.5. So I'm going to plot that and just estimate where that is. So 7.5 in there and 447, something kind of like that. Okay, and I'm going to label that vertex for what that is. Okay, so what the question is what is the lowest cost? So which number is the cost? It's the 447, right? Okay. So what the problem said, if you read the problem, is the X was, this is the number of videos rented, I think is what that is, and then it said Y is the cost. So the answer to the problem would be 447 is the lowest cost. Okay. So like sometimes I teach a business calculus class, and we do a lot of economics applications where we do things kind of like this, and we do it with calculus methods, okay? All right, is everybody okay with the calculator and how we're doing that today? Okay, all right, okay, so that'll wrap us up today, and if anybody else needs to turn in that great goodie or needs help after class, just see me, because we do need to get that in today. Do you have a question?
Yeah. On the answer key for that, it says 678.
Sometimes those answer keys on that are off. Let me make sure I put the right thing on here, because I got the right graph there. So it looks okay. What did they have on that one?
678.
Did you guys do it with me? Did you get my answer?
I got the same answer.
You got my answer, okay. So I pull those out of a computer program, and every now and then they generate something wrong. I don't know why, but they just do. There's bugs in the program, I guess, okay? All right, very good.